Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm making this video for the purpose of CSC159 Computer Organization course in UiTM. In this video, I will discuss about the add instruction in assembly language. Add instruction performs the addition operation in assembly language. The add instruction will add the value in source operand to the destination operand. And the sum of the addition operation will be placed in destination operand. And the source operand will remain unchanged, meaning that the value in the source operand is untouched or remain unchanged. So the syntax of this operation is add destination source. Add destination, comma, and source. For example, add AL 30. Okay, in this example, 30 is in decimal number. You have to remember that in assembly language, the decimal number will be converted to hexadecimal number during the operation. Okay, let's take a look at the first example. Okay, in this example, we are going to add immediate value to an 8-bit register. Okay, as you can see here, we are going to add 100 with 20 in decimal value. The instruction given is we have to move AL with 100, meaning that 100 will be inserted into AL register. So you have to remember that any decimal number will be converted into hexadecimal number in assembly language operation. So now, when we want to move AL 100, so 100 decimal must be converted into hexadecimal first. So 100 in decimal is equal to 64 in hexadecimal. Okay, so it is 64. And then we are going to add AL 20, meaning that the 64 in AL will be added with 20. Okay, so 20 is the immediate value. AL is the destination register. Okay, now we have 64 plus 20 in decimal. So 20 in decimal, when we convert it into hexadecimal, is become 14. Okay, 64 plus 14 in hexadecimal. So 4 plus 4 is 8 and 6 plus 1 is 7 in hexadecimal. So 64 plus 14 in hexadecimal is equivalent to 78 in hexadecimal. Now, the new value in AL will be 78. So 64 will be vanished. Alright, so in addition operation, the 4 flags here, okay, also will be affected. But here in this result, none of the flags is affected. Okay, the 0 flag, the sign flag will be 0, 0 flag will be 0, carry flag will be 0, and overflow flag will be 0 because none of these flags is affected. Okay, next example. Okay, this is example of adding immediate value, also the immediate value, to a 16-bit register. Now, we are going to use AX instead of AL. Okay, so the instruction is move AX 200. So 200 in hexadecimal is C8. Okay, when it says move AX, so you have to write in AX. Okay, so move AX 200. 200 is 00600 C8 in hexadecimal. So you have to write 00C8 in AX, not AH or AL individually, but AX individually. Okay, and then add AX 20. So 20 is 14, and then the answer or the sum will be inserted into AX. Okay, now we add 00C8 plus 1, 4. So 8 plus 4 in hexadecimal equal to C. C plus 1 is equal to D in hexadecimal. So here the new value of AX is 00 DC. Okay, so in these instructions, the flags here are also not affected. Okay, because the result does not trigger any flags to be equal to 1. Okay, the third example is to add 8-bit register to register. Okay, we are going to add register with register. Okay, how register with register will be added? Okay, the example is add AL and BL. Okay, so first of all, we have to insert a value into AL and BL. Okay, for example, here we have move AL 35. So 35 in hexadecimal is 23. So move AL 35, meaning that in AL there will be filled by 23. And then move BL 200. 200 in hexadecimal is C8. Now BL will be filled with C8. Then AL plus BL. AL is 23 and BL is C8. And the result will be inserted into AL. Okay, let's add the number together. Okay, 23 plus C8 in hexadecimal. 3 plus 8 in hexadecimal is equal to B. 2 plus C in hexadecimal is equal to E. So this is the answer, and the answer will be kept into AL. Okay, so AL here will be placed with E and B. Okay, in this example, one of the flag is triggered. That is the sign flag. Now, the sign flag here will be equal to 1. 0 flag equal to 0 because the answer is not 0. Carry flag is equal to 0 because there is no carry. And overflow flag is equal to 0 because the number is still in the range. Okay, so why sign flag is triggered? Okay, this is the reason. Okay, let us convert the number of EB into binary number. Okay, so the binary version of EB is equal to 1110 and 1011. Okay, this is E and this is B. Okay, why sign flag is equal to 1? Because the leftmost of the number, okay, the leftmost of the result of the number is 1. So whenever the leftmost of the result is 1, then the sign flag will be equal to 1. Because it is a sign of the number that we get from the calculation is the negative number. Okay, because the leftmost number is the sign whether the number is positive or the negative. So now the assembly language has assumed that the result of this number, of this addition, is negative number. So how are we going to fix this? Fix this flags or fix this situation? Because we know that EB is not a negative number. Okay, 23 plus C8 in hexadecimal is equal to EB, and EB is not a negative number. It is a positive number. How are we going to fix this situation? This situation can be fixed by using the 16-bit register. Okay, meaning that you cannot use AL and BL, but you have to use AX and BX to make this kind of operation. Okay, because the number, the result, okay, will trigger the sign flag to be equal to 1, and indirectly tells the computer that the number that you get is a negative number. Okay, let's take a look at the last example. Okay, this example is about adding 8-bit memory to register. Okay, now we are going to use a memory operand. Okay, now we start with count db40. db is a declaration for 8-bit memory allocation. Okay, so the memory allocation is named as count, and the value that is given to count is 40. Okay, 40 in decimal, and in hexadecimal it is 28 hexadecimal. Okay, now let's move to the second instruction, move BL 100. So 100 in hexadecimal is 64. So in BL there will be 64. Now add BL count. So in BL there is 64 in hexadecimal, and count there is 28 in hexadecimal. So add 64 with 28. So 4 plus 8 is C, and 6 plus 2 is 8. So the result is 8 and C. So 8 and C will be placed in BL. Okay, so now 64 will be gone, and it will be replaced by 8 and C. In this situation, the sign flag will be changed into 1, and also the overflow flag will be changed into 1. The sign flag is triggered to 1 because 8C in binary is equal to 1000 1100. So once again, the leftmost number in binary is 1. Therefore, the assembly language emulator assume that the number formed or the result is in negative number because the leftmost of the number is number 1. Okay, so how to avoid this kind of situation? You have to use 16-bit register and memory. Okay, another thing is the overflow flag also has been triggered into 1. So why overflow flag is triggered? Okay, according to our textbook, okay, this overflow flag is triggered because of 140 in decimal number or 8C in hexadecimal number is out of 8-bit range. So what is the 8-bit range? Every group of bit number has its own range. Okay, for example, 8-bit positive number has a range of 0 to 255 in decimal. And the sign 8-bit number, the range is from -1 to 8 to +1 to 7. Okay, now the operation has made the sign flag to be triggered into 1. So now the computer has assumed that this is the sign number. Okay, this is the sign number. 8C is a signed number, 140 in decimal is also a signed number. Okay, so the range of the signed number is between -1 to 8 to +1 to 7. So now, the result that we get is 140 in decimal. So the result that we get is 140 that is out of this range. Okay, we have only the range between -1 to 8 to +1 to 7 for the sign number for 8-bit range. Okay, so we are using the 8-bit register now. Okay, move BL. BL is 8-bit register, and count DB. DB is also for 8-bit memory. So 8-bit range for signed number. Why it is become signed number? Because the leftmost of the number in binary is equal to 1. So this has made the computer to assume that the number is a signed number. Okay, so now it is a signed number and it is out of range because 140 is more than 127. Okay, so therefore the overflow flag is triggered to 1. Okay, so I think that is all for addition in assembly language for lab 3 in CSC, for lab 3 for CSC159. Okay, so see you in the next video of subtraction instruction in assembly language. Thank you so much. Bye-bye.